today we will see what is known as a Cauchy problem. Cauchy problem is the one which is going to tell you about the existence of the solution to a differential equation, and if the solution exists, then it also will tell you whether the solution is going to be unique or not. So that is what is known as the Cauchy problem, also known as the initial value problem for the first order differential equation. Of course, the statements will change for higher order differential equations. So you can follow the blue color cursor that is there here. Now what is the point to be noted in this particular diagram is that we are going to consider some kind of square region. Now what is this epsilon here? So epsilon is going to be a small number approaching 0. In mathematics, most frequently used symbol will be this epsilon, and typically what is the meaning of epsilon is a number that is going to approach 0, and for practical purposes we can have numbers like 10 to the power minus 5. So that means what do you mean by that is that we are interested to consider the region of space, what we are going to call by the name domain. So what is your domain? That is the question. The answer is x is lying between 0 and L, y is lying between 0 and h. The second thing is what is meant by an epsilon neighborhood. So you have an x0, y0, and then about that particular point you are going to draw the circle, and therefore this is known as the epsilon neighborhood about the point x0, y0. So that is the terminology. Then you have the gray color. This is the blue and this one is the gray color. So the entire gray color region is the entire domain, so including the circular region. The full region, the full rectangular region is known as domain. So this is the usual way that we are writing. So the style in which mathematicians write, that should be very clear. So this is the standard notation that we have, and the terminology will be a domain. And what is this R2? This is not square, this is R2. 2 means 2-dimensional, and this kind of R, what you call, either we can say that it is calligraphic R or a script R, whatever you call it. Or we can say that the letter with a double stroke. Okay, you have R had 2 lines are there. So that kind of R is reserved for set of all real numbers. R2 means 2-dimensional. You can also write R3, 3-dimensional. R4, R5, anything can be written for n-dimensional, mathematically speaking. And in any case, complex numbers are not allowed to enter. Cauchy theorem for the basic existence and uniqueness. So I have written like this, that it is a theorem talking about the existence of the solution and also about the uniqueness of the solution. Now how the statement will look like? Okay. So now we can see that if the two of these conditions are satisfied, where our interest is only the domain D, then we can immediately make a conclusion. So what conclusion you can make is there exists a unique solution. We will call by the name phi for the differential equation in some interval, that within this small circular disk centered at x0, and h is going to be a small, that's what is written here, where h is going to be sufficiently small, we have a unique solution. Not only that, the condition number 1 tells that the solution exists. If the condition number 2 satisfied, the solution is unique. So these are the 2 conditions. Existence is first one. If the second one is also satisfied, then not only it is existing, it is also unique. Okay, so keeping this theorem, what do you want to do? So in the case of the competitive examination, it will be quite comfortable to ask a question like, given the differential equation, there will be 4 options. First option will be saying no solutions. The second option can be saying that there exists a solution. The third option is there exists a solution but not unique. And the fourth option will say that solution exists but it is also unique. Okay, so let us go back to the board now. And now let me move on to show an example problem. I'd like to show an example problem in this case. Now what you understand from this diagram is, okay, the equations are same. You have the first order derivative dx by dt will be the right hand side a function of x comma t. So why I am giving this example is that I am now showing that time t can be one of the axes in mechanics. So on the horizontal axis I am showing the time, and the vertical axis can be the position of a particle, okay, which is moving on a plane. So that can be x. And then the region of interest need not be rectangular, need not be any particular shape. So So that's the reason why I am choosing some kind of blue region, which is not a particular shape. We are interested in the solution of this differential equation, x dot equal to f of x comma t. So that is all about this particular diagram. And when the x-axis is time, you see that the x-axis is a time here. Whenever the x-axis is a time, this particular problem is known as initial value problem. Why it is called initial value means you have to start the experiment. If you don't start, then experiment itself will not be executed, right? If you have a chemical reaction or if you have a simple pendulum, you have to start the oscillation. If you don't start the oscillation, then pendulum will not oscillate. So that is called initial time. So that is the meaning of initial value. And then coming to the domain, you have this kind of a symbol. You have omega. Omega is capital Omega is the traditional symbol for the domain, and this particular symbol is a subset. So what is the meaning of subset? You can understand. R2. R2 means what? It's a two-dimensional plane. So two-dimensional plane means it's infinitely large, right? On the x-axis, it can be infinitely large. On the y-axis, also infinitely large. So the entire plane that you have, right, that is known as the R2 plane. R2 plane means a two-dimensional plane which is generally of infinite extent. Extent means infinitely large, minus infinity to plus infinity. So we are not going to consider that big one, but instead within this such a large R2 plane, we are going to consider a small region. That is what is known as subset. Anyway, it's a subset of R2. That's all about it. Okay, so what is the purpose of writing? Understand, right? R2. So R2 means two numbers are there, t comma x. That's all about it. Now I'll write down the condition for the continuity, which is already known to you. Because this particular statement is already written in the theorem, so the same thing I am writing here.